Hi, everyone. In this lecture, we're going to finish up z-scores. So we're going to do a few more examples just to make sure we really all understand the concept of a z-score and how to apply a z-score. So we're going to do examples 13 to 16, and then we'll move on. So let's look at number 13. So example 13 says the mean height of a basketball team is 6.3 feet with a standard deviation of 0.2 feet. Height follows a bell-shaped distribution. The team center is 7 feet tall. Find the center's z-score. Is his score unusual? So you're being asked to find a z-score for this center who's 7 feet tall. But before we do that, let's just extract the important pieces of information in the problem. So we know that the mean height of the team is 6.3 feet with a standard deviation of 0.2 feet. So let's write that down. So we're going to use mu for the mean since we're assuming it's for the team of all basketball players. There's no mention of a sample. So mu is equal to 6.3 feet. And the standard deviation is equal to 0.2 feet. And we have this center that's 7 feet tall. So x is going to be equal to 7 feet because that's the height of this particular player. And we're also told that height follows a bell-shaped distribution. So we can imagine what height looks like, right? We're imagining that bell-shaped curve with a mean of 6.3 in the middle. So we want to find the center z-score. So let's just write down the z-score formula. So z is equal to the data value minus the mean over the standard deviation. And if we plug in for this particular problem, we're going to have 7 minus 6.3, which is the mean, and we're going to divide that by the standard deviation of 0.2. So when we plug this into the calculator, we get 3.5. So this center has a z-score of 3.5. So what that means is his height is 3.5 standard deviations above the mean. Now, the second part of this question is asking, is this score unusual? And let's remind ourselves what we talked about in the previous lectures. If we're working with a bell-shaped distribution, any data value that's more than 3 standard deviations away from the mean, we're going to consider an outlier or unusual. So since this player's z-score is 3.5, which is more than 3 standard deviations above the mean, we're going to consider his height unusually tall. So yes, his score is unusual since it is more than 3 standard deviations from the mean. So hopefully this additional question or practice problem on z-scores is solidifying, the meaning behind a z-score and how we use it. So remember, z-score measures how many standard deviations a data value is from the mean. And if we were working with a bell-shaped distribution and we have a data value that's more than 3 standard deviations away, we consider that value an outlier. So now let's move to example 14. So example 14 says, the z-score of a student's exam grade is negative 1.45. Let's just stop right there. Imagine I told you that on your exam that you took, your z-score was a negative 1.45. Now, that doesn't tell you what your actual score is, but the fact that it's negative tells you that your score was below the mean, right? Because a negative z-score correlates to a data value that's below the mean. So you know you did below average. So if I go on to tell you that the mean exam grade is a 75, which of the following, and here's the key word, could be the value of the student's grade? Now, we're missing the standard deviation. So that's why we can't calculate the actual value of the student's grade. But based on the fact that the mean is a 75 and your z-score was negative, which puts you below the mean, which could be the value of your grade. So but this is multiple choice. But before we look at any of the answers, you know that your grade has to be less than the mean, and the mean is 75. So which one of these choices could be the student's grade? So which choice is below a 75? And the only choice is a 64. So you didn't even need to pick up your calculator, pen, pencil, paper, nothing. This was just more of a contextual problem where you just had to think in the context of the question. And you had to be aware of the meaning or definition of a z-score. So example 15 is similar. The z-score of a student's exam grade is 0. And I talked about this in the last video. So remember what it means if the z-score is equal to 0. That z-score of 0 corresponds to the mean of the distribution. So I go on to tell you if the mean is a 65, which of the following is the value of the student's grade? So the fact that the z-score was equal to 0, that means that the grade, the corresponding grade, is the mean, and the mean is equal to 65. So that's going to be choice B, 65. And let's look at one more. Example 16 says if the z-score of a student's exam grade is positive 2.35, so let's just stop right there. The fact that your z-score is positive, that means you scored higher than the mean. So right away, you know your grade was better than the mean. And I go on to tell you that the mean is 70. So you can definitely say that your grade was better than a 70. So which of the following could be the value of the student's grade? So which choice here is greater than 70, right? That's the only possible grade that it could be, and that's an 87. So I think these examples, 14, 15, and 16, are nice because it's just testing that you understand the meaning or the definition of a z-score. You didn't have to make any calculations, right? That wasn't necessary. So I think at this point, we've had a lot of practice with z-scores. We've done a bunch of examples, and you'll also have an assignment in my stat lab to also practice with. So in the next lecture, we're gonna begin looking at raw scores.